Welcome, everyone. Welcome to this webinar, Next Steps for Improving Road Safety Through Enabling Technology and Autonomy. It's a great pleasure to have you here at our PAVE Europe webinar. My name is Lukas Neckermann. I'm a co-founder and board member at PAVE Europe. PAVE Europe is a not-for-profit, Europe-wide organization focused on educating the public on the benefits of automated mobility throughout Europe. We're a membership-led organization, over 25 members strong, from Waymo to OXA, Swiss Re, Mobileye, Simulix, or PwC, Zeekr, and many more. I encourage any viewer of this webinar to seek out PAVE Europe as a source of information, and also, if you're in the industry, like so many of you will be, to apply to become a member company of PAVE Europe. I'm very, very thrilled to have you here today, and I'm also very thrilled to have our panelists here today. And just a very, very quick introduction, who we have joining us today. We have Justin Hyde, who is the Director of Corporate Communication and Media Relations at Mobileye. Wonderful to have you join us here from Washington. Justin.
Thank you, Lucas.
We have Richard Damm, who is the president and chairman of the Kraftfahrtbundesamt, KBA. So many of us rely on your data and so much more, but you're also part of the UNECE Working Party on Autonomous Vehicles. Welcome, Richard.
Thank you. Thank you, Lucas. Pleasure to be here.
We have Dr. Maria Alonso, who is the portfolio lead for autonomous systems at the World Economic Forum. Welcome, Maria.
Thank you. It's a pleasure to be here.
We have Biagio Ciuffo, the senior project leader at the European Commission for Autonomous Vehicles. Biagio, welcome. Finally, we have Dr. Ian Greenwood, the independent campaigner to stop road deaths, based here in the UK. I say here in the UK as I'm hosting this session today from London. First, some facts. Injuries and deaths from crashes are still among one of the greatest avoidable tragedies that we have. And let me highlight two words in that sentence, crashes, because it's more accurate to call a vehicle crashes and not accidents. And the second word is avoidable. Avoidable because we have technology, as we'll talk about throughout the course of this webinar, to avoid so many of those crashes and save lives. Europe has managed to decrease its road fatality rate by about 15% over the last decade, which sounds like great progress on the one hand, but it still lags woefully behind its own targets for Vision Zero. Vision Zero, of course, being the campaign to drive road deaths to zero. And the US, for comparison, well, there's no other word for it, but it's a disaster. Road fatalities are at the highest point in 4 decades, and bearing the brunt of that is vulnerable road users. And we'll get into that in some detail. An important difference between the two, not the only difference, but an important difference, is that the EU has mandated a number of ADAS features to serve both occupants of a vehicle and vulnerable road users. Other countries, including the US, is, well, they're miles from doing that. So as a result, we still suffer these consequences. We know that technology alone isn't the solution, but today's focus will very heavily be on technology because we are talking about autonomous technology. Allow me to add for this panel, I represent PAVE Europe today, but my views don't necessarily represent PAVE Europe in its entirety. That is very normal because PAVE Europe strives to share a diversity of opinions and views, and you can be very, very sure that that is going to be the case today. So without any further ado, I'm thrilled to get going on this webinar. And Ian, I'm going to start with you because you literally wrote a PhD thesis on the politics of road deaths. You remember the UK's Parliamentary Advisory Council for Transportation Safety. So in your view, what's the relationship between autonomous technology and road fatalities. Ian.
So, Lukas, thank you for the invitation. It's good to be with everybody. Good afternoon, everybody from Yorkshire in England. So we know this stuff. So we know that an estimated 1.19 million people die on the world's roads every year. And we know that it probably shouldn't take very much to improve those circumstances that cause those deaths, many of which are caused by us humans. So to answer your question, Lukas, the relationship is that AVs will stop road death, isn't it? But it's not that simple, of course. So by way of introduction, I used to work in the health service in Britain, and I just wanted to share a little bit of experience from the 1990s. So I used to run health services. And in the 1990s, I remember discussing robots with a neurosurgeon back in the day who'd been off on fact-finding on an aeroplane somewhere and came back very, very excited, absolutely full of enthusiasm about innovation, about the power of technology, how to improve patient outcomes, how to reduce human error, human harm, as well as surgery. But back then there was very little data and there was very little evidence of efficacy. So at the time, we didn't actually buy a robot for this particular very enthusiastic neurosurgeon. The main reason for that was cost, combined with he wasn't able to persuade his colleagues within the neurosurgical team at that hospital back then. He was an innovator. He's right at the front of the queue. He remains very excited. He's retired now, actually, a long time ago. But fast forward many decades, neurosurgery with the use of robots is just normal. That's what happens. If you have neurosurgery and it's one of the procedures that you need that needs robotic assistance, that happens. Nobody really bats an eyelid. The data is there, the evidence is there. It's very, very clear. And for me, it reminds me of the same debate, I would suggest, from somebody from not within the AV tribe. It reminds me of the same sort of debate about the development of autonomous vehicles. So the question for me sounds really quite simple, Lukas. So what I say about injury trauma, it is caused by humans for whatever reason, whether that's drugs or drink or human error or not being able to see the junction because of weather or eyesight problems, whatever that might be. Autonomous vehicles will, of course, be safer, won't they? But the relationship between the two, I would suggest, is very complex and far from simple. So I would suggest 4 things. As I said, somebody from outside the industry, I've got four observations that I think might be helpful to people. So firstly, do we actually have a problem that needs fixing? Some people might say, well, that's 1.19 million people globally. Of course, we've got a problem. So maybe a strange question for somebody that campaigns to stop road death. But my own research has shown that if policymakers, and I talk about policymakers first, if policymakers do not see the need that we've got a problem, and they don't see the need for them to act in order to legislate or get involved in this space, then we haven't really got a problem that is worthy of solutions to stop road death. If we can't persuade politicians, then it's then more difficult to persuade everybody else, except those innovators like the neurosurgeon right at the front of the queue. And if the current framing that Europe, I'm going to pick on Europe, has some of the safest roads in the world, reinforces a view that there is no need for change. The debate about safety stays very technical. It stays within the tribe, and that is therefore less accessible to many who are outside the tribe, like myself. So that I would suggest impacts very directly on the speed of adoption and getting people interested in this space. Secondly, demand from drivers. Are drivers demanding change? And if drivers are reluctant to adopt technology to assist driving, such as intelligent speed assistance or lane assist or whatever that might be, because most drivers are better than the average, aren't they? So they don't need any help, do they? Or quite a lot of them don't think they do. So, for example, on behalf of the UK driving population, the last UK government refused to implement the general safety regulations, which are now mandated across Europe. For reasons known to them, we don't need to explore that today. But I would suspect that the freedom to drive how and when drivers want to drive was a big part of that. And I won't mention Brexit, and that was probably part of the mix as well. So whilst many have recognised that we do have a problem, and those in the AV world have persuaded many policymakers and others, I would suggest that maybe lots of possibly older drivers do not think that we've got a problem that needs fixing. Paradoxically, whilst the last British government refused to legislate for different forms of assistance, they were very, very keen on autonomy and did lots of work in that space. And I don't want to focus on the UK too much, but that is where my area of expertise is. But I would suggest there is confusion about the technology, which influences the demand from drivers for change. And I would suggest that better knowledge and understanding, certainly for somebody from my perspective, would help shift the dial. The third thing, and the last two are a bit quicker, because I won't ramble on too much. The third is language. So a big part of my thesis was about language and framing, and how language and framing influences policy, but also how that influences discourse. So I would argue that this is really very important. So framing this space, road death or road driving, road safety, as the safest. It's all very complicated, isn't it? That driving assistance is the same as autonomous, right? I don't really know what the difference is. Crashes are unavoidable, the point that Lukas made at the beginning. So people call them accidents, because accidents we can't do anything about, can we? Because they're just accidental. That's why I always talk about crash like Lukas does. Also, and this is very much a personal view, the language in this space seems very, very confident. I have done some research before I joined the seminar, and it seems very, very confident. It seems very assertive. It seems very optimistic. It's kind of coming next year language I've seen quite a lot when I've read things. I'm not sure that's shared by your average driver in Europe or the US or maybe elsewhere. And the last one is data, and I'm not going to dive into the space too much from my point of view, not my area of expertise, but I would suggest that in order to engage better, the accessibility of data and the believability of that data that is available can help persuade people that AV are safe, or at least safer. I think that needs more attention, and education will be the proof of that, I suspect. So to answer your question, Lukas, the relationship between AVs and road deaths is crystal clear to those within the tribe, I think. But I've suggested I'm not sure that it's a very simple question, and I'm not sure that we've managed to persuade many people that that's the case yet.
That's one of the reasons that we're here today. It's one of the reasons we have this webinar. It's one of the reasons for PAVE and PAVE Europe that we communicated to much further than our own tribe, and that we highlight those benefits to everyone. But at the same time, there's kind of different levels and different times, and we'll certainly get to those throughout this webinar. And maybe there's also a short-term and a long-term solution to road deaths and crashes. Let me turn to Maria for this one, because the World Economic Forum put out a working paper together with a consultancy on advancing autonomy as a measure towards greater safety. But Maria, if I get this right, basically your focus was very much on the short term and the greatest impact in the short term. The paper talks about L2, L2 plus, L2 plus plus, and we can surely have a debate about whether some of those levels exist or whether they should be called that, or if those are just misnomers. But leaving that aside, we're talking about ADAS, and you're suggesting that vehicle autonomy by way of ADAS can have the greatest impact in the short term. Can you expand on that and maybe talk a little bit about the paper that you've published?
Yeah, Lukas, and the reason why we looked into L2, L2 plus, as you're saying, is because that's where we see volumes increasing today, right? So when we're looking into L4 vehicle autonomy, no doubt that is where we can really achieve those safety levels that we are all aiming for. This is not something that we can hope for in L2 plus, but this is what we can have today in the streets. This is what we already have today in the streets at a larger scale. So when we are currently actually looking into trying to better understand when the different levels of autonomy will be expanding into scale. And when it comes to the private vehicle sales, which are the majority of the vehicles that we see around us, still in 10 years' time, we expect that 1/3 of those vehicles will be L2 plus. And only around 10% of those vehicles will have L4 capabilities. And we've been discussing these numbers with executives from the automotive and the tech industries, and they're very much aligned. So if we are seeing that it will still take some time for L4 privately owned vehicles to really be there at scale, then what we can do today to improve road safety is to already leverage the possibilities, the capabilities that the cars that are already today at a price level that we can mass produce are being leveraged in a way that are contributing to road safety. So that was the key of the paper. one thing what I would add is that because we still have the human in the loop, some of the aspects that now you were discussing on drivers being drunk, drivers not paying attention, that's still something that we have. And we have also an additional challenge, which is that we're being asked to pay attention to 100% of the time, while we only need to intervene in 1% of the time or in 5% of the time. That is a difficult task. And this is one task that we need to make sure we're putting forward in all the educational possible to make sure that those new drivers that go into their new cars with some of these ADAS capabilities, which do have the capabilities to help us with road safety, those technologies are used such that they're going to contribute to our safety goals.
There's certainly a lot to unpack there, Maria, because first of all, you talked about L4 and privately owned vehicles, and there's certainly a case to be made that a lot of the L4 vehicles may not be privately owned, and they will operate in fleets or in public transport, and frankly, also different vehicle categories. Certainly in Europe, that'll be the case. In the US, let's say the verdict is still out. You're absolutely right to talk about ADAS, and let's push this out as much and as quickly as possible. We know that there's a great benefit. Something certainly we encourage anytime, and I speak with a lot of fleets and fleet managers. I say everything that's available, make sure that it's on there because it does save lives. So we'll talk a little bit more about that, maybe the statistics, but I do also want to get to Justin from Mobileye on this one because, well, Justin, you represent an AV developer on this panel, and Mobileye, of course, has a distinct view on advancing autonomy through the various SAE levels. On the one hand, I don't want to talk and focus too much on L1, 2, 3, 4, 5 because it's so strange, really, that even those levels have become this kind of public thing. Why should the layperson have to worry about levels? It's either I drive or I don't drive. It could be really that simple, but you have some nuance to that, Justin, at Mobileye. And that has a consequence as well for road safety. So maybe share with us what the nuances are for you and also what road safety means to Mobileye.
Certainly I will, and thank you, Lukas, and thank you to the panel. It's a real pleasure to join everybody here today. I think it's important for me to step back a bit and talk about where we come from at Mobileye and how we approach the question of autonomy and automated driving and assisted driving a little bit differently. So our company was founded 20 years ago by our founder and CEO, a pioneer in computer vision, Professor Alonso, and he was someone who was able to take the emerging field of computer vision and apply it to automotive safety in a way that hadn't really been possible before. First with things like collision warning, and eventually evolving further into assisted braking and now automatic emergency braking. And through his work and the work of our company and our colleagues, we've been able to take those systems and help make them widespread around the world. Our company alone has produced 180 million chips or systems and cameras to power vehicles around the world and to help improve safety through advanced driver assist systems. And so that experience of having safety at our core and trying to create it at the broadest possible scale kind of informs everything that we do when it comes to developing autonomous vehicles. The first lesson is that it does have to be able to scale. You know, if you are trying to build something that only works in a small location or costs too much to build, you're really not going to be able to make the goals that are necessary to show the benefits of the technology. And the second thing is that it does have to have a cost benefit to it. There has to be a business behind it. And I think that's something that has been a real struggle in the industry over the past 10 to 15 years, and something that is a struggle still today. But if you can address those two challenges, there is a tremendous benefit available to have a reduction in road deaths and to improve safety globally, not just in developed countries, but really around the world. Lukas, to your question about levels and how that informs us, I think as a communicator, we talked earlier a bit about framing, and Ian, you mentioned this, framing how we talk about our problems. And from our side, we certainly do not really believe that the SAE levels are that useful when it comes to communicating the capabilities of an ADAS system. We tend to have a different framework we use that focuses on hands-on or off, eyes on or off, and driver in the loop. So for what would be a level 2 system, your hands are off, but your eyes are on, meaning that you are still in the loop and watching what's happening to the vehicle, even if your hands are not necessarily on the wheel. There will be a level 3 vehicles where you have both hands off and eyes off, where the driver may be able to take their attention from the driving task. And from there, you go into full autonomy. And we feel that being a little more precise about how the systems are used on the road will help everyone understand what their capabilities are and to avoid the abuses that may come into the system if you're not clear with users and with regulators about what the system's capabilities are. I would say too, from our perspective, being members of PAVE and as an industry, when it comes to developing and deploying autonomous vehicles, really safety has to be a bedrock principle. It's not something that can be seen as some kind of competitive advantage from one company to another. It doesn't help demonstrate the value of the technology if it's a race to safety. Safety has to be something that happens automatically when these vehicles go on the road. And I think that's a key reason why it has taken time to develop both the technology and the business, because everyone realizes there needs to be this very, very high level of safety before we put these vehicles onto the road.
Super interesting point, because that if safety is the baseline, then we can build on top of that, because the business models that you alluded to, and also frankly, how do we monetize this, is then a question of, well, yes, it's time saving, and whatever it's named, and strangely, every OEM, of course, has a different name for it, and maybe that adds to some of the confusion. And if we then throw in things like pluses and 2s and 3s and whatever, that also contributes to the confusion, because people don't know, am I allowed to do what, when, where, and how? Given that amount of confusion, there is a regulatory component to it, which takes me very, very naturally over as well to Richard. You have been on the UNECE working group on AVs, but also representing the KBA, and with that, all of the OEMs that ultimately need to get their vehicles registered. What do we need to do in Europe to get some sort of standardization and ultimately get greater road safety by pushing out more and more and higher levels of autonomy? Richard.
Yeah, thank you, Lukas, and it's a good discussion so far. In terms of safety, I think it was mentioned by Maria already. We don't see so many level 3, level 4 vehicles on the road yet. The majority of the vehicles is individually driven vehicles which have assistance systems on board. So if we'd like to improve road safety in short term, it's clear we have to focus on assistance systems. And at the UNECE, as you might be aware, a new UN regulation 171, was put forward and has entered into force in March 2024, so half a year ago. And this regulation is called the Driver Control Assistance System. And what it has the text of the regulation is a focus on the HMI, the driver involvement, which is essential. So I always take the example of current assistance systems, which requires a hands on the steering wheel. So that's the detection. But you can look outside the side window and the system will not complain. So this means you're not, as Justin said, not engaged in the driving loop anymore. If you look outside the side window and the system is not complaining and you have just the steering wheel in your hand. So what we did is we took a different approach and have set up a new UN regulation on this driver control assistance system, DCAS in short, to go for a more generic approach to allow technology being brought to the road, but improve it in the safety level. And we at KBA, we don't call it level 2+, level 2++, but we call it extended assistance systems because it has an improved HMI on board, an improved driver monitoring, which will drive safety in the right direction. So with the new system on board, and it will of course take some time until the first systems are going to be approved according to this regulation. With such requirements on board, it will not be possible anymore to text on the smartphone, which is possible today. You know, you can have one hand on the steering wheel and do texting on the smartphone. This will not be possible anymore with this new regulation. And last month, no, 2 months ago in September, end of September, we have taken a second step with such new UN regulation. We have put forward an amendment. This is going to be voted at the World Forum for Harmonization of Vehicle Regulations in March next year, and entering into force will be later on in autumn 2025. And this new amendment will allow to take off the hands of the steering wheels and also allow automated lane change. So it's some kind of evolutionary step towards automation. It's not yet level 3. It's not yet level 4, but it gives more opportunities for the user of such systems for a maturity of vehicles on the roads. And that's, I think, where we have to look into if we'd like to improve road safety at the short term and medium term. I think for the long term, it's quite clear there will be more technologies, especially in the area of level 4, but it's currently too premature to speak about safety when you don't see the technology on the road and not at a scaling factor. We of course have vehicle tests going on, but they are very much on a supervision and controlled and so on. That's not the real world scenario we would expect when we have scaled the level 4 technology in more vehicles. But so on short term, it's focusing on the assistance systems, and it's more in the mid and long term when level 3 and especially level 4 will become more important.
Okay, Richard. I'll come back to that point a little bit later on, because in terms of regulation, there are enabling regulations, and then there are regulations also that hold us back. And certainly from a European point of view, we need to get that balance right. We know and we see that, of course, in China and also in the US, we have very, very significant deployments of fully autonomous driver-out vehicles. We don't have the same level of, and then it's the same scale of deployments in Europe, which I guess takes me to Biagio at the European Commission. What's the EU's aim with respect to getting the balance right between road safety and deployment of full autonomy?
Thank you, Lukas, and also thanks to all the colleagues, all the panelists here. Really, I cannot agree more with all what has been said until now. Well, European Commission has always had road safety as one of its priority. We have been, of course, road safety is not just vehicles. Road safety is a lot of infrastructure. I think since the start of the European Commission itself, there have been actions towards the increase of road safety, focusing very much on the infrastructure side, on the passive safety of vehicles, and so on and so forth. So you also mentioned in the introduction how the situation is in Europe with respect to other countries. At the same time, as Ian said at the beginning, the fact that Europe maybe has the safest roads in the world doesn't mean that we don't have a problem, quite the opposite. And this is certainly acknowledged also by the political, by the European policy. In the last strategies that we have 5 years ago with the first von der Leyen Commission, one of the key elements on transport was exactly safety. And inside that strategy, maybe for the first time, put at the front of the strategy was the contribution by autonomous vehicle, automated vehicles. the 10 years before were focusing more on making the infrastructure, supporting intelligence in the transport and mobility. So the CITS concept is cooperative intelligent transport system, definition of relationship between on the definition of requirements and standards for the communication between vehicles and infrastructure, with the objective to provide the driver with the updated information and everything that is needed to drive as safe as possible. Now acknowledging that we need a further step, and the step is to provide the vehicle with the onboard intelligence to act on its own and prevent as much as possible. So as much as possible accidents. So all the accidents that can be avoided by technology shall be avoided. Of course, this doesn't mean going directly to level 5 automation, because we know the challenges that this implies, and therefore also at the European level there is it is acknowledged the complexity of developing and deploying fully automated systems. So whatever can contribute to increase the safety of the vehicles is welcome. So ADAS as first. Now you said mandatory, a number of elements for ADAS and also driver monitoring system, but of course level 2, as we have called them before, and the DCAS, as Richard correctly pointed out, a UN regulation that provide requirements for the introduction of this system. And this is very important because you mentioned US, where deployment is happening. It's true. This is deployment is happening there, but at the same time, it is happening without a level playing field, without a regulation, without any requirement for these vehicles. We actually take advantage of US. We have carried out a number of testing campaign with vehicles deployed in the US. We know that there are already a system with more advanced functionalities also available on the market, but we see that these vehicles will not comply with the DCAS regulation that was mentioned before, meaning that what we aim in Europe is to try maybe not to start as quickly as it is happening in the US, but to really start in the right way. So with vehicles that are able to really ensure an increase in road safety.
Would it be fair to say that because we've done so many other measures in Europe to improve road safety, the pressure isn't as much on rolling out the highest level of autonomy?
If it's still to me, no, I don't think so. The pressure is there. The pressure is there. It is. We acknowledge the complexity. We want to, in Europe, we want to start with in the best possible way to avoid mistakes. Because if we don't have a clear regulatory framework in place, we open the door also to systems which may be labeled as automated, autonomous, full self-driving, whatever, and not in reality not deliver what they promise to deliver on the road, which may eventually jeopardize a fast introduction of this technology if people realize that they are not really contributing to their safety.
All right. Thank you as well for, in your answer, giving a comment on the CITS, which was one of the questions that we received before this webinar from a participant. Thank you to that participant for submitting your question. And if you have questions for this fantastic panel, please do just on screen, go to the Q&A button at the bottom of your screen and do type that question in. And I'm going to take one of those questions right away. It fits actually quite neatly in right here, because on the topic of infrastructure, AVs need to work with infrastructure, and whether that's a digital infrastructure or physical infrastructure. Ian, I'm going to turn to you in the context of a safe systems approach. So we know that Vision Zero, of course, requires many, many things to play along, whether that's the infrastructure being right, whether that's the penalties for speeding and distracted driving being sufficient, whether that's connectivity enabling things like alarms within alerting the driver, also monitoring of the driver, awareness of drowsiness, et cetera, et cetera. From your point of view and your research that you've done on road safety, what do you think would bring us furthest along, and how does infrastructure play a role here?
Lukas, thanks for the question. For me, I'm a campaigner interested in policy, so I'm interested in the question. So I probably haven't got a very technical answer to your question. So I think two givens for me. One is safe systems is a very big part of the answer, and anything we do should be within that context. And not surprise you to hear me say that the second thing is that accepting that we do have a problem, lots of people do, some people don't, is a really big part of this, and therefore having brave politicians and policymakers within this space that can actually move this forward, like I would suggest the EU do, and have them for a long time. Within that context, what would I advocate? Well, I love the safety gadgets on my Volvo, so I'll start there. I'll make it very personal to me, and I think that's really quite important. So I make a flippant point, but I think there's a serious point behind it as well. And I like those gadgets, or at least I would say the ones that I understand. And I also think that's quite an important point as well. But I do worry about the ability. You mentioned infrastructure. I do worry about the engineering. I do worry about the infrastructure to help deliver them. So I live in rural Yorkshire. It rains a lot. So what happens to some of the gadgets and the sensors and the systems when it rains, or when the white lines on the roads aren't necessarily very visible and the junction isn't very clear, and all those really practical things. So I think that those are issues, and people on your call will hear that I'm talking from a very non-technical point of view. So I will try and answer your question though. So what I would say though is tech that works for me in my environment, to make it very personal to me as a driver, to my environment in where I live. I think that's really, really important. Tech that's explained to me in a way and language that I understand. I think a lot of the language that is used, as I said earlier, is confusing. I am somebody who tries very hard to understand. I'm now in this space. Lots of people aren't, so I think the language doesn't help people in terms of what systems, what technology might be most beneficial. I would say that tech that avoids overly complicated advocates, chief execs who get very excited and overpromise, switches me off. So I think people and people from within the tribe that can commit the promise in very sensible terms rather than just marketing. And it's proven. So I'm obviously, as somebody that's done a PhD in researchers, I'm interested in the data that backs all of this stuff. I think that's really important. But data that is understandable and accessible. So rather than moving away from optimism, it's going to be wonderful, isn't it? Well, actually, I want somebody to explain to me how that's going to happen. What do all the different levels mean to me? I like the way Richard described it earlier in terms of making it very practical in terms of what I would need as a user. So I think that the engagement and the education part of this is really very important. And I know that's why we're all here today. And I've looked at your question in terms of which tech I would want. But I hope that's helpful.
Yes, absolutely. Thank you, Ian. Maria, turning to you, because your report also identified user knowledge and understanding as a key barrier to the deployment of autonomous technology. So, of course, this is why we founded PAVE Europe. But beyond knowledge, how do we shift from user awareness of autonomous technology to real action? How do we generate action in support of road safety?
Yeah. I think still we should keep in mind that knowledge is the cornerstone. So it starts with what Justin and Ian were saying now. It needs to be very clear terminology. Eyes on, eyes off, hands on, hands off. I would argue the third one is mind on, mind off. Do we have to really be aware that we are in the car and that the car may need to take over? That's the first thing. They need to understand what we're talking about. And then we need to be able to have across the learning journey new checkpoints to make sure that they are getting aware and then they're being able to use this technology. Otherwise, there's a barrier of entrance. We know how to use our mobile phone because we use it every day. All apps come every couple of weeks with some updates, but we are all the time using them and we are forced to use them. if we are not forced to use the new technology in the vehicle because, hey, I know how to drive, why should I even put it on? Then we have that barrier to actually use it. If we have that barrier to use it, then what at the end of the day comes out to is people turning those functions off. And if they turn off those functions, it also means that they're not going to get any safety benefits that they could be getting from it. Another thing which Ian also referred to before was the fact that we all think that we're very good drivers. And if I'm a very good driver, why do I need that system? This system, everyone else needs it, but hey, I know how to drive. And I believe there are some statistics that say that 80% of the drivers think that they're among the 50% best drivers in the world. Well, there's something in the maths that do not really come together. So those things, I would say, they're the very foundational ones. And then the industry also has a very important thing to do, which is to make sure that the products work right. Right now, there are many times when the driver is asked to take back the control in situations where, in theory, they would probably not need to do that. If that's what they experience again and again, there is a new cognitive loads of being needing to be ready to take action, and then it's easier to not do it at all. So from the industry perspective, I think it's extremely important to make sure that we're putting forward products that are really ready for the usage, and that everyone who's using them does see two things. First, the convenience of using them, and second, the safety benefits that they will get from using those products and from having those around them use those products. So making sure that those products are really the right ones is the second piece after making sure the education is right. And then I would say, when we're talking about having the human out of the loop with L4 fleets, then what we can see from some deployments that we see, for example, in San Francisco, is that when people use it and they see that it works very well, they're very eager to use them. It was some decades ago, I don't know exactly when, that elevators used to have someone to make sure that they were actually going up and down.
It took decades. It took decades before the elevator staff was.
But right now, I actually prefer that the elevator doesn't have a human who's the one responsible of putting me up or down. It will be the same if we make sure that we're offering products which indeed contribute to safety. And as Justin was saying before, we cannot compete on safety. And this is actually what I would say is the challenge of the industry. Because right now we are competing on safety, because that's where the competitive advantage is bringing us forward. But if we're saying that that's actually the baseline for this industry to take off, how can we make sure that we are competing on something else and that we are all contributing to those safety benefits, which are going to take fully off this vehicle autonomy reality that we are all hoping for the sake of human lives on the roads?
We are competing on a number of different levels. We're competing, companies are competing with each other, of course, to roll out the benefits, and those benefits maybe in terms of time savings, as we mentioned earlier, or yes, indeed safety, but also so are countries competing to have deployments. And of course, the starting points are very, very different. Maria, you said that it just has to work. And Ian said earlier, it has to work in my neck of the woods where it's raining and there are leaves on the road and it's foggy. And my situation is perhaps different. We have a question from the audience as well, who says, what about driving conditions on Indian roads, which are different once again? And we mentioned earlier as well that maybe there are different standards that are going to be in place, whether there are deployments on Indian roads, on European roads, maybe even different countries in Europe. And in the US, we already have different standards in various states in the US. Justin, from a Mobileye point of view, this must get really, really confusing. And how are we going to have software, hardware, technology that addresses the different levels of required safety, the different levels of road infrastructure, and all of that, even connectivity infrastructure? Justin, how do you master it at Mobileye?
Well, that's a huge question there, Lukas, and I think that's something that the industry as a whole that's the key question to the industry as a whole. Let me talk a little bit about how the AV industry works broadly, and then bring it back to kind of how we address this at Mobileye. And I think you see two situations right now when it comes to autonomous vehicles. A lot of autonomous vehicle companies will focus on a single city or a single location. They will kind of try to master that city or location, and then plan to take those learnings and apply them to different locations sort of one by one. And there's certainly some benefits to doing it that way, but at Mobileye, we think there are some disadvantages to that as well. And the technical term that you hear is called overfitting. And overfitting is when you design a system so that it will work in this block, or it will work in London but not Paris, or New York or San Francisco but not rural Missouri. Our experience going back again to our ADAS systems, we design these systems so that they are in multiple countries and multiple regions around the world. And your questioner mentioned India. We are selling ADAS systems for India today. And yes, there are some very specific things to India about recognizing what may be on the road. We have an example of teaching our cameras to understand what a seated cow looks like on the road, and that is something that needs to be avoided, because that is something that happens in India. But there are generalized rules of safety and generalized approaches that you can take based on some of the things that we have done in ADAS to make sure that we have an overall safety framework that can work in any location. And it involves, you think about sort of sense, plan, act when it comes to autonomous vehicles. So first thing is sensing. And Ian, this goes to your point, how does my technology work when it's raining? How does it work in unusual circumstances or unusual conditions? It's important that your AV has robust sensing. And for us, that means redundancy. Our AV systems are designed with both cameras and then radars, LiDARs, and a newer technology called imaging radar. And the idea there is that you are not just relying on one type of sensor to get an idea of what's happening around the vehicle. You are relying on multiple sensors that work in different ways, so that if one has a challenge in a situation, another one can fill in and provide the necessary data. And those sensors can be then used in different parts of the world, and not being reliant on a particular geography. The second step goes to planning. And you think about, if you're inside the vehicle in an L4 system, deciding where to go. That's where you start getting into system design, and you get into system safety and things like, we have a system called RSS, Responsibility Sensitive Safety, which is essentially codifying rules of the road. Don't ever cause a collision. Right of way is given, not taken, for example. And using those as a baseline, which can then be adapted to different driving styles around the world. Certainly, drivers in New York are going to be different than drivers in a small village somewhere in Germany. So you do need to have some flexibility in your system, but you also need to have core safety rules that can be broadly applicable. And finally, it comes into acting and making sure that when you finally do when it goes to act, it has made the best decision possible. Here, that's where we rely on AI. And we have a system we call compound AI that blends sort of the best of what's new in AI with end-to-end sensing with some rule-based systems, so that the choice is not just the right choice, but also a transparent choice. When AVs start to hit the road, I think one of the key features that they're going to need is that they have to be transparent in their activities, not just to the people inside, but to people outside, to the safety system that exists on the roadway, and to regulators broadly, so that if there ever is a question, why did this AV perform in this way in a certain location, it can be understood. These are all things that we see as essential to make the technology scalable. There certainly are a lot of hurdles to making them scale, and obviously the industry has been struggling to get through those hurdles over the past 10 or 15 years. I mean, you can go back to the 1980s even, where some of the initial experiments in building autonomous vehicles said, oh, well, it'll be just a little bit of time and we'll have vehicles that can drive themselves. It really does. It's not just a matter of getting the technology right. It's a matter of making sure the technology can scale, that there is a benefit and a cost analysis that allows it to be applied broadly. We don't build full autonomous vehicles. We're building the technology that goes into vehicles to enable them to be autonomous. And that's one of the key pieces and strategies we have to try to make sure this technology is democratized as broadly as possible.
I'm so glad that you mentioned redundancy, but you also mentioned cost. Now, redundancy and cost seem to be at different ends of the scale, and we know that there are some in the industry that feel differently about redundancy, and very possibly, certainly after the events of this week and the election, we may find that redundancy isn't a necessary component. I'm going to turn to Richard on this one. First of all, when we head towards full autonomy at the highest levels, would you agree that full autonomy requires at least two systems so that we have redundancy? And second of all, could that vary by country? In other words, could the US allow for full autonomy without redundancy, whereas other countries require redundancy, and therefore there's a significant cost difference?
Yeah, thank you. And I think Justin just mentioned it. So when you look at the deployment of highly developed system, I would call it like this, you always see a redundancy in the sensor technology. And this is not only because there are some pros and cons with the different technologies, so the different sensor technologies, but it's also about reliability and safety. So to reduce the safety risk, you have to go for multiple sensor technology, as described before. I think just relying on one technology at the current stage, with the current computing power and the current level, state of the art of AI, it seems not to be feasible that with one technology you can provide a safe system at the different levels for different ODDs and so on. So what we see is that most of the manufacturers rely on different technologies. That's the first point. Second point, about the UNECE work, I think we are trying to work hard to put requirements in place that are technology neutral, let me call it like this. So it's requirements which do not demand a certain technology to be used, but are performance oriented. In other words, there is a requirement a manufacturer or a supplier has to fulfill, and the choice is up to the manufacturer, the OEM or supplier, to check what kind of technology he can use to fulfill the requirement. And this is really a basic requirement of the work at the UNECE, and what we are currently doing at this UNECE working group GRVA for automated and autonomous and connected vehicles is working on a global regulation together with North America, with Europe, with Asia and other regions around the world to come up in mid of 2026 with a regulation that can be applied worldwide, so globally, and delivers the safety level we all like to see. So the idea is not that the US or China or any other country comes up with different core requirements, but that we collaborate together, try to set up a harmonized scheme for the basic requirements of such systems, and that's where we are heading to, which does not necessarily mean that some manufacturers will go one way or the other. So it depends how far technology is developed, but at this stage, at the current level, we see the necessity for such redundancy as Justin just described it.
Thank you. So that regulation will certainly apply to four-wheeled vehicles or multi-axle vehicles, but there's also a consideration around two-wheeled vehicles. Turning to a question from our audience today, what solutions are there for two-wheelers, motorcycles, primarily? Biagio, let me turn to you in the European Commission on this one, simply because you have a statistic that's published every year on vulnerable road users crashing with buses and trucks and cars, et cetera, et cetera. So the first question, I guess, is how do we use the AV technology to make the rider of a motorcycle safer? And second, how do we use it to make vulnerable road users that are not protected by the shell or even protected by a bike, such as pedestrians, safer?
Well, let's say for the motorcycles on board the vehicles, automation, I think it's something that will not happen very soon, but certainly the role of connectivity can play a very important role for any type of road user. The possibility to get communication about upcoming vehicle, blind spots, and so on is also a research field which is quite active to understand how to take advantage of communication between vehicle infrastructure and other road user to increase road safety. Of course, from the point of view of the motorcycle, cyclist, pedestrian, of being vulnerable road users because they are vulnerable with respect to the cars, of course, automation plays a very important role, because the possibility to continue, the fact of not being distracted, the fact of having sensors that are continuously monitoring the road, independent on whether we are talking about sensor of a level 2 or level 3 or level 4 system, but still we have sensors that are continuously monitoring the environment around the vehicle. This is expected to really play a big role in reducing crashes, not accident, crashes on the road involving vulnerable road users, which are those with the highest rate of mortality or of several injuries. So from this point of view, we expect the automation really to deliver significantly, especially in urban context, as soon as the technology is ready to be deployed at scale.
Thank you so much. We are coming upon the end of our webinar, and I'd like to turn to everybody in one sentence or less. What gives you the most hope in terms of the autonomous vehicle technology improving road safety? Let me start first with Maria in one sentence or less.
That we have that common goal of improving road safety, and hence using that goal as what steers our actions.
Thank you so much, Maria. Ian, your thoughts?
Oh, what a question. I'm an optimist, so what do I think? I'm optimistic that the human endeavor will stop road death, as we have in other transport modes. There you go. I'll be optimistic.
Powerful message. Thank you so much, Ian. Richard.
Thank you, Lukas. And the global collaboration at UNECE, with a commitment from all of the countries around the world, with a focus, with safety as a focus in mind, is quite promising. And this ensures me that we will deploy safe technology.
I love that, safety at the core. Absolutely right. Biagio, your thoughts?
My hope is that industry will find the right balance between profits and safety. So that's while developing their solution, they will also guarantee the highest level of safety possible.
Thank you so much, Biagio. And finally, Justin, your final thoughts on this?
I would say history shows that we can accomplish great things in improving automotive safety when we work together with the right technology and with the right frameworks. And I think that's what makes us all optimistic about the potential benefits of AVs.
Collaboration. I love that final message. Thank you all so much for your great insights for today's panel. Thank you for joining us. Thank you as well to the audience. for joining us. Lots more questions came in that we didn't have time to. Please do continue to engage. Please make sure to subscribe to PAVE Europe and reach out to us anytime if you have questions on road safety and autonomous vehicle technology. Thank you so much. Have a wonderful, wonderful day, and hope to see you all soon at another PAVE Europe webinar. Have a great day. Take care. Bye-bye.